Hey, what's going on, guys? Kins here. In this video we're gonna be talking about Bitboards. What is this, how they used within the chess engines, what pros and cons they have, and actually why to use Bitboards in your chess engines. But before that, I'd like to share some sort of an insights I came up with after creating 40 plus videos on this chess programming channel that we're kind of covering the process of development of the very simple chess program based on hexadecimal 88 board representation, which is generally an array-based board representation, where the entire chessboard is represented as an array of integers, where every element might be either 0, which is the empty square, or some sort of an encoded value. Some sort of an integer value, like 1, 2, 3, whatever, that represents the particular piece on chessboard. Say we can encode white pawns as 1, then white knights as 2, and so on. But it's not the point. The problem is that chess programming is such a sensitive topic that it's incredibly difficult to take a decision to actually get into there, to jump into it. And I understand that just making this straight ahead tutorials, like, okay, so let's write a chess engine, so you would be following for 40-50 videos until at the very end we'll have a working chess engine that would crush some other chess engine. So after doing after having this experience on YouTube, I've realized that it's not the way to go, basically, because nobody really cares. And I just got 22 subscribers, sorry, that has come from my main channel, the Kins channel, related to web scraping and web development, which I'm making money on. But they just subscribed just just to do me a favor, basically. So it's not the case. I believe that, like, do me a favor is definitely a good thing, but if you're not interested in the topic, it's not that there is no much sense of following, basically. So what I came up with so far regarding this issue, that instead of going I just can compare this with the modern versus old school TV series. So let's compare, let's say, for those of you who has been watching the science fiction Star Trek series. So what's the difference between the Star Trek Discovery and the Star Trek New Generation? The difference is very simple. In Discovery you have a series where the entire story is divided into separate episodes. So if you miss an episode, you can miss the entire story, and that's incredibly important thing to bear in mind. While if we have a look at the Star Trek Next Generation, it doesn't really matter that much if you miss, say, from 5 to 10 episodes, and then you just get back, and then you can get away again, and then get back away, and you won't really miss much, because every new series, every new episode within that series, through all the seasons we had there, we have an absolutely kind of independent story that is trying to tell you some truth about the human life, human being, and things like that. It's not really much even about the science fiction or some fantastics like that. So I will try to follow some sort of a similar approach on this channel in my further videos. So I would be trying to make every single video kind of independent from the others, and instead of continuing some sort of a source file that has been created in the previous video, I would be well, at least I will try to be to write everything from scratch every time, and to cover just a very little parts of the material. So it won't be like a series to let's create a Bitboard chess engine, because well, first of all, there is a nice series on creating a Bitboard chess engine by Logic Crazy channel that does this in Java. And even though I don't like Java still, and there is a huge issue with unsigned with unsigned integers, especially unsigned long type, which is available in C, but in Java there is some sort of an issue with that. Not sure exactly, but I remember he was suffering from Logic Crazy was suffering from that sort of an issue, and try to invent something something on his own to bypass that to bypass that issue basically. But that's not the point. So I just believe that starting a new series on like let's build a chess engine in C, the bitboard using the bitboard move generator. If you could ever imagine the amount of work that needs to be done in order to do that, and amount of code. Oh, somebody has subscribed. Thanks, man. Yeah, celebrate. Hey there, man. Thanks for subscribing. So the problem is, I'm just wondering, did he subscribe to CodeMonkeyKing's channel or to chess programming? I don't really remember what kind of account is now available in my browser. Well, probably that the web scraping channel, I believe, but doesn't matter. So it's incredibly long journey to create a bitboard. I'm not even talking about the chess engine, but the move generator. It's incredibly long journey, and it's incredibly hard to follow that. So what I want to say, that there is an interesting part. There is an interesting stuff is about to be revealed when communicating on Talk Chess Forum, where guys who are making chess programming for 30 plus years are interacting with each other, sharing their ideas, and making their engines to play versus each other, and having fun from that. So even though there are really lots of people who actually can write a strong bitboard based chess engine, I mean it's not like 10 or 20 people, so there are really hundreds of people, believe it or not. And even though those hundreds exist, they are so close. I mean they're closed, their inner world is closed. They're not about going widespread and talking about what they're doing and how exactly this could have been done. So this looks like something like when you have a solid science like physics, and there is some scientists who are not who don't really care whether their science would be popular or not. And on the contrary, there are guys like I guess Richard Feynman, if I'm not mistaken, who was kind of trying to make the physics popular, or I don't remember the guy's name who was trying to make popular the idea of the string theory in physics. But that's not the point. So there are always the vast majority of those guys who actually doing things, they are not about to widespread these things, say on YouTube or resources like that, but they're just doing their job, and they're not really that likely to interact with others, but those who can do the same basically. And how I observe my goal is actually, instead of only doing this, I would also like to widespread this. So to make you guys kind of touch this chess programming stuff, because it's really it's not about money, obviously. It's about your self growing as a programmer, because when I just started, all I could do was just to follow the patterns provided by some other programmers without much understanding of what's going on under the hood. And now what really makes me happy and what pleases me the most is actually to implement the algorithms that are already known, but just doing that on my own way, and doing that following some sort of my own patterns, like development patterns, life patterns. So just trying to do things on your own. That's something that really pleases you when you're doing the chess programming. So because there are so many ways of how one can write chess engine that you can't ever imagine. Literally, as many developers out there. So that's the exact number of the ways to create a chess engine, even though the patterns are all the same and the logic is the same. But still, if it comes to the real coding, it's incredibly difficult to find two similar engines. even if one man writes chess engines along his life, like I did, I didn't, I never, I've never written strong engines, but I was fond of making, say, the mode generator in different ways, uh, organizing the board structure different ways. My last try was actually to make to make board array and side of move in peasant square and castle in variables to be completely global, and that was also interesting, even though you might wonder that the global variables are evil in general, but nevertheless it worked, and that was really fun. So what I wanted to I will definitely leave the timestamp in the description below this video for you guys actually to be able to skip this unnecessary talks by Komakikin and just get straight to the point, basically. But just a few words before we actually get to our chess engine, to our bitboards within the chess engines. So the problem is that if you can't if you're not capable of creating a chess engine on your own, then it's incredibly hard to follow someone else's tutorial, not because the tutorial is bad, but because when you follow someone else's tutorial, you're kind of diving into his own life, into his nature, into his coding habits and things like that, and you're losing the gist essence of chess programming behind the personality of the developer that explicitly spreads from his code, basically. So that's the problem, actually, and it's incredibly hard to pick up those pearls of the gist of the chess programming, the clearest, the purest form of it. It's incredibly difficult to get that from when a person actually writes the chess engine from scratch. So it's not a matter like I promise that if you follow this tutorial you will create a chess engine. At the very end it would be working and it would beat some other engine. It's not the point, basically, because I just want to share my experience regarding this stuff. That's, by the way, that's the exact way that how I got started with chess programming. So probably you know that there is a great series called Chess Programming Chess Engine in C, Programming Chess Engine in C by Blue Fever Software, who was creating 12 to 10 based board representation, 12 elements multiplied by 10 elements, so 120, yeah, elements within the board array. That's another. Okay, just I don't really want to go to these details at this moment. So the point is that he has, I'm not sure exactly, but probably for about 80 videos, and for about 40 videos, about after 40 videos, the engine that he's developing there is already kind of working and is capable of playing versus other engines. And I've been following for about 40 episodes of that series, and I did actually copy his engine, and that helped me really a lot. And after I tried to do things on my own, but the most issue that I've been encountering since that is that actually every time I try to make something new, I've realized that I was copying the Blue Fever Software's WISE chess engine. It was called WISE, from which stands for Video Instructions Chess Engine. Yeah, Video Instructions Chess Engine, like that. So every time I was trying to make something on my own, I was realizing that I'm just making a poor version of WISE again. And when I realized for the first time that I can actually change something and come up with some sort of an interesting solution on my own for the very first time ever, I was so excited, because even though the engine was working pretty similarly pretty the same way, still I couldn't still it was incredibly addicting to do things on your own, basically. So I just want to give you a couple of examples. So the first thing I did, so Blue Fever software was using make move function followed by the take back function, and he tried to so first he made a move, and then you just need to take the move back. So he was incrementally updating the board on make move, just not only move the piece but also change the side of move and do lots of stuff there, and then everything but in the reverse order with the take back function. But what I did is known as the copy make approach, when instead of incrementally updating the board back in order to take the move back, you just copy the board structure before making a move, and then when you need to restore the board, you can just reference that copy that you've created, and that's it. That's very simple. Another trick I used was in order to being able to make the question search, which serves the purpose of getting rid of the harassment effect in the Nigamax search algorithm. So in simple words, just to avoid your chess engine giving pieces away when he thinks, like when the queen captures the pawn, he thinks that is better, and then the pawn captures the queen and you're queen down after all. So in order to avoid this sort of a behavior, there is a technique called the question search, and the difference between the question search and the casual Nigamax search is that within the questions we need to generate only capture moves instead of all moves like we do in the Nigamax alphabet search. So what Blue Fever did, he did double his generate moves function, and then just removed those moves that were not captures. So that's the way he went there. And the way I found how one can actually handle this, I just added an extra flag to the move encoded into the integer. So we were encoding moves into integers, like from square to square, promoted piece if any, then some flags like pawn start flag if the double pawn push appears, capture just did this a bit later on, so pawn start flag, castling and passing flag, and I've also added the capture flag. So the idea is to distinguish between the captures and quiet moves on the make move function level. So the idea is when you're having a move that your engine asks you to make, you can distinguish between the quiet moves and the captures. So say I just added an additional flag argument within my make move function, so I could say whether I need to do all moves with my make move functions or only captures. So, and within the question search, I just pass this only captures flag along with my make move function. So when the make move function occurred, it actually was checking whether this flag is enabled or not, and if it is enabled, it just did those moves that were captures. Otherwise, it did basically nothing. So that was another idea that I've used. Obviously, even though I didn't see this approach before, but I'm 100% sure that this technique is known among the chess engine developers. But still, it's really interesting to come up with things like that on your own, basically. So what else I want to say? What else? And one last thing regarding this. Regarding the move ordering, basically. So like in order to optimize the alpha beta search, it's incredibly important to take care of move ordering. So you first, it would be nice to make those moves that would be causing the beta cutoffs, and this would reduce the bandwidth of the search significantly. And the better your move list is ordered, the faster your search is, because the last nodes are being traversed during the search at a given depth. So that's another thing. So, and in order to make the move ordering, we need to score the moves. So Blue Fever's implementation did make use of having a move structure where we had a move integer and the move score, so two variables within that structure. And then he just and he was scoring the moves within the add move function that was called from the move generator. So literally something that is not really related to the move generator was done within the add move function that was actually responsible for so add move function was responsible for the move generation. Like it's kind of a bridge between the move generation and the move list. So the idea of add move function is actually to populate the move list with the newly generated moves by the generate moves function. But also, it did score the moves. So later on, when the search occurred, the engine was sorting the moves. So to put the most valuable moves first, so, and well, in simple words, just to sort them in the descending order. So, but I went slightly different approach, and I used. So first, I came up with a bit wrong implementation, which gave me not always the best results. I was trying to score the moves on the fly, but later on I just added some middleware function that actually let me to associate the scores with the moves by creating an array to store the scores for every single move within the move list temporarily, and then I was just and as far as the moves were associated with those scores, I just used the descending sorting algorithm in order to do both. Just sort those scores and sort the corresponding moves. And eventually the result was the same, even though this approach seems slightly slower compared to the embedded move scoring within the add move function used by Blue Fever software. Still, that was something I made on my own, and that was something I invented on my own. Probably I've reinvented the wheel at some point, and probably this is bad from the performance perspective. But again, like I'm just trying to show you that the motives that are driving you when you're making a chess engine might be so different from one person to another. So the idea is actually why am I talking about this? Yeah, so I'm talking about this because if you're trying to make a series like in Star Trek Discovery style, then you're forcing people actually to follow your you're forcing people to follow your your internal process and your understanding, and you're just you're forcing people by addicting them to something that might not be that natural for them. So and when I did this series, so I've created this Wukun chess USI chess engine that was actually using of this as I was already mentioning the board the array-based board representation where we are encoding moves with the integers. So this the off-board squares, pawns, black pieces, white pawns, white pieces, and E stands for the empty squares. So quite pretty simple and straightforward. And the problem with this, no problem with this approach. It works. It plays for about 1600 elo points. Slightly worse than TSCP, that is rated 1683. I guess the version 1.88 on CCRL chess computer chess rating list site. But when I was doing this series, even though I tried to make it modular, I tried to make it like not try to make it non-personal as it possible, as far as it was possible. But still, I believe that for those of you who has an experience of coding in C, you would probably say like I'm doing many things wrong, and you would do this on your own, like a different way. And those who has no experience in C programming, again, even if you will follow this series from the beginning to the very end, yeah, you will get the working engine. It's not a problem. Even though after making the mode generator, I try to separate this process and try to make the search separately from the entire engine. So I was making my version separately, and then I was making a series of tutorials on Nigimax search separately as well. So just to give you an idea that when the mode generator is done, you can use your own creativity to optimize the search the way you want, basically. But even still, the problem there was and is that even if you just follow all those tutorials, and if you will get the working engine at the very end, and you'll see the results that I've been showing you within these videos, if you just if you really recreate those results on your local system and see how it plays versus other chess engines, and even wins from time to time, even then, you would be sticking to the Komaki-Kins implementation, and it's not good because like if your goal was to just to write a chess engine, so just as a proof of concept to make sure it kind of works and you understand what's going on there, in this case this might be just fine. But well, probably everyone starts with this. I was starting with this idea as well. So first I just wanted to it took me 3 years to write my first bug-free move generator that was capable of passing the perf test, believe it or not. So yeah, I understand the desire to write a chess engine that actually you understand how it works, and you can replicate it as many times as you want, and that's quite pretty nice. But when you're done with that, you're starting to realize that the idea behind creating chess engines is not actually to prove the concept that this is possible, because as far as when you're doing this for the fifth, sixth times in a row, you understand that this is actually possible, and you're starting to understand that you're limited with those patterns you came up with while following someone else's tutorial, and it happens that one day you would want to make it on your own. So you would try to you would like to start getting some content describing the essence of the topic itself, not the impersonated implementation, but the pure topic itself. So I hope this is clear, because this is the most important part within this entire video, and probably now I understand that I will probably just so I will leave this as an intro, and then I will make another video actually that would be dedicated to Bitboards, because I'm probably talking for too much already, but I really wanted to share this stuff with you guys, because this is absolutely essential. So just to summarize all I've said within this video, and to finally finish this video, hopefully, I just want to say that it's far more important to understand the topic. So which parts does chess engine consist of, like board representation, move generator, search function, and the evaluation. So board representation and the move generation are really tied together, so it's incredibly difficult to separate them. So it might be considered as the single part. So literally there are three parts within the chess engine. So move generator, then the search function, and then the evaluation. And obviously they all are connected to each other. And the most interesting thing that the way you represent the board, and respectively the way you generate the moves, actually affects the way you evaluate the position, because evaluation of bitboard based boards is completely different compared to evaluating the array based boards. And by the way, that's one of the most important differences between bitboard based chess engines and array-based chess engines. So we may say that bitboards are faster than the array-based chess engines, but not that significantly, to be honest. And like when I wrote my first bitboard chess engine, it was actually 5 times slower compared to the array-based one that I was writing before that, and I was really confused. Like, oh my god, they told me that bitboards are faster than the array-based move generators. Then why the hell my move generator is so slow? And obviously later on I make this. I actually did manage to make it faster than the array-based move generator, but still, the amount of code and effort spent in order to achieve that was really significant. So Actually, the reason to use bitboards is more like for the evaluation purposes rather than for the speed of the move generation, because the speed of the search doesn't really rely that much on the speed of the move generator. If you optimize search really nicely, if you add some transposition tables, your move generator doesn't need to be kind of light fast. It may be just a casual move generator. It's not the point. But when it comes to the evaluation, the idea is that so there is always a trade-off between the speed of the search and the quality of the evaluation, which means that if you have a very complicated, sophisticated evaluation function, it would slow down the search significantly. And otherwise, if you have a very light evaluation function that does not really that much, then just the bare material evaluation, say positional piece scores like that, like my Wukong chess engine did. In that case, it speeds up the search significantly. But if you're playing versus the engine that has exactly the same search speed like your engine does, but at the same time that engine has a much better evaluation, your engine would would be losing all the time. It's doomed to lose due to the poor evaluation function. So the bitboards is something that is designed to minimize the slow down process of the search during the evaluation. So bitboards lets you evaluate positions really fast, and that's one of the most benefits. But obviously I would have covered this in the next part, and now I already understand that would be the next part of this video, actually explaining the bitboards. But nevertheless, it's I just wanted to highlight this within this video. So I guess we can stop the very first part at this point, and in the next part, hopefully, I will try not to describe my own experience in chess programming, and I will try to drop those philosophical questions regarding chess programming, like why to do this and so on. And I promise you guys, I will try to focus on bitboards. But again, just to make it more clear for you to understand that when I would be writing some code regarding bitboards, I really want this code to serve you as some sort of a, like if there was a Wikipedia of code, and basically probably there is some, I don't know, but say the chess programming Wikipedia, which is an amazing resource for chess engine developers. It does contain some implementations from time to time, but they are very general. Well, in order to make the chess engine work, we need to go for particular implementations. And again, even though the particular implementation actually involves the personality quite heavily, still I would have tried to divide and conquer the material, so you would be getting the gist essence of how to work with bitboards. And as far as the overall concept would be clear, I think you will be able just to write your own bitboard move generator without following a series. And at this moment, that's the exact goal I'm currently aiming, basically. So this is it. Well, okay guys, so see you next video, and hopefully we would have been talking about the bitboards. Okay, so until the next time, and take care.